You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm lucky to be joined by Dr. Stephen Mattingly, a postdoctoral researcher from the University of Notre Dame in the US. His research centers around the study of sleep, stress, and memory in humans and how these can be measured and predicted with new sensor technology. I'm very excited to learn more about his work and how it intersects these rapidly growing disciplines. So thank you for joining me today. I really appreciate you taking the time to talk a little bit about your work, and I'm very excited to learn about some of the different applications you've been working in. But to start off, I'd love to just ask you to quickly introduce yourself and some of your research interests.
Sure. My name's Steve Mattingly, graduated with PhD in cognition, brain, and behavior from the University of Notre Dame. I started graduate school in the sleep, stress, and memory lab under Dr. Jessica Payne. Then I've transitioned into longitudinal data from the Net Health Project and the Tesserae Project. And my interest really specifically now has evolved into how do we measure sleep, how do we measure stress, and how do we apply it to the real world.
Mm-hmm. And when it comes to these different topics, I know you talked about how your work has kind of evolved over time. And looking in from the outside, it looks like you're working with a lot of very different areas, from sleep to memory to stress, which some other psychologists might not be. But what's really interesting to me is how your work connects these disciplines of psychology, which might seem very different, but unifies them with the common aspect that you look at with how technology plays a role. So could you quickly talk about how some of your work has been applicable across a bunch of these different psychological domains and just some of the technologies involved there?
Sure. So these domains, one of the things that's very common across all of them is that they're sort of hardware based. You have this stress system, and when you're stressed, it changes how your brain takes in information, processes information. And so there's a lot of intersectionality, and I think that's really the future, is taking the knowledge from these various domains and stitching them together and kind of getting that combination, or where the sum is greater than its parts. And so that's where I kind of started, but I've kind of evolved into taking those lessons in the lab and kind of applying them in the real world. But before that can happen, we have to make sure that when we use it out in the world, that we're getting what we think we're getting. So just as a kind of example, the common clinical grade sleep measurement is called polysomnography, or PSG. You glue electrodes to people's heads. They have to sleep in your lab for 8 hours. You have somebody monitor. It's a really big production, and it takes a really large amount of effort to get done correctly. And we really just can't take that technology out into the world. It's prohibitively expensive. So I've been investigating wearables and smartphones and their intersection, and using those as measurements for sleep. But we found that they're really kind of not as accurate as PSG. So, they may be off by an hour or even two. And if you're saying someone's sleeping 6 when they're really sleeping 8, that's the difference between perfectly healthy and recommended sleep and clinically sleep deprived. And these can be very different states that people are in. So I'm very much interested in making sure that that measurement translates into the real world so that we can then apply laboratory lessons into the real world. One paper we did recently was looking at cell phone usage and wearables, and we found that when we combine them, we were able to get much better sleep measurements, because some of the reasons wearables fail is that people are still, but they're doing something while they're awake, like looking at their phone, checking email in bed, setting alarms, whatever. So the wearable says, oh, this person's still, they must be asleep. And on the flip side, if you look at people's phones, a lot of times people engage with their phones, but the phone is also doing stuff in the background that isn't prompted by the user. So you might get a text message at 2 a.m. That's not you being awake, but that's your phone doing something. So when we kind of put these things together, use both the motion-based sensor of the wearable and the cognitive assessment via the phone, we were able to get much more accurate sleep measurements than either stream alone. And we got off about 8 minutes from self-report. And so that amount of accuracy makes it useful to other researchers. Being off by 8 minutes is not a big deal, but being off by 2 hours is a big deal.
I think that's a really cool application of these more modern technologies, and it kind of makes me wonder, before we had these technologies, how did people go about trying to study these things in, say, the 50s or 60s, before we even had things like laptops? And I wanted to ask that because it kind of makes me wonder, what are the things that we can study now that literally wouldn't have been possible back then? Or even in the case of these wearables or smartphones that we're using, wouldn't have been possible 10, 15 years ago.
Psychology as a science has always been tied to technology. So even behaviorists, sort of way back in the history of psychology, they kind of didn't have all the tools that we have. And so they started by saying, we're going to look at stimulus in, response out, and we can't, anything in between, they call it the black box. They can't say anything about what's happening in between. They can just say, I put this thing in this mysterious machine of an animal model or something, and then out comes the response. And then as the technology developed, things like MRIs or CAT scans, where you can kind of peer into a brain in vivo, then you can start saying, well, the black box is a little narrower. We can't say what's going on in the individual neurons, but we can say this region of the brain is activating during this task, and it's tied to this other brain region. And you kind of, as these technologies improve, they allow a deeper understanding of what's going on in the middle. And so basically technology, as it continues to grow, will continue to shrink that box or make it smaller and smaller. I don't know if it'll ever get rid of that box. I think there'll always be a more specific space to look in, but that's the kind of thing where technology can really improve the mechanisms. So the wearables and the social media and the phones, what we're going from an individual person, now we're also looking at a wider context. So like, kind of like we talked about before with the sleep lab, you can only hook up a couple people using these very expensive machines a night to get it sleep. But with wearables, we can look at 1,000 people at a time, or 10,000. I mean, there's really no, the limit is effectively the funding, but it's amazing how much more practical it is to look at 1,000 people at a time. And so this technology allows lessons from lots of people together, as opposed to lessons from within a person in their own context.
When we think about these new findings, especially at this increased scale, it makes me realize how different a discipline in psychology might be when it comes to applying some kind of technological measurement compared to some other sciences, even in the social sciences with things like economics. People are usually looking at large scales. I didn't actually think about this until now, but often if you're going to be measuring things, especially with psychological research, then the numbers are going to be quite small. What kind of findings are you coming up with this new unprecedented access?
Yeah, the one of the interesting and unique challenges of psychology, sociology, economics, that kind of thing, as opposed to, like, say, physics and chemistry and everything else, is the inherent base unit, the person. We are inherently variable, day to day, hour to hour, minute to minute. I woke up this morning, I felt great. I was hungry, I was in one state, I had breakfast, now I'm in another state. And so if you ask me questions about how I felt right when I woke up, they may get a different answer from the same person on the same day. So our basic unit of measure is variable, whereas things like, chemistry, it's like, if you've got this specific atom, it's always going to react in this certain way with this. It's a very one-to-one process. You can really plan that out, versus psychology and sociology and those kind of things, where there's not a very stable foundation. So you really need a lot of measurements across a lot of people across a lot of time. So that's kind of one thing that I think is important to realize. As a specific example of a finding, though, so we had college students who wore wearables for 4 years, and we looked at their bedtimes and their heart rate, and we found that people who vary their bedtimes, either going to bed later or going to bed earlier, have higher resting heart rate than people who are more narrow with their bedtimes. And these effects persist into the next day. And this is interesting because this also controls for amount of sleep and for time of day. So really, it's truly a variation in bedtime increases resting heart rate, which is a biomarker for a lot of unhealthy things, mortality, obesity, etc. And so it's interesting because it's, most previous research was focused on the duration. They say, you need to go to bed and sleep 8 hours, that's the most important thing. I still think it is, but this is sort of also showing that not only is going to bed and sleeping 8 hours important, sleeping regularly, going to bed at the same time every day may also be an important thing for your health, or at least could be. I mean, more research is always needed, but it's certainly something that's only enabled. We were only enabled to find this across 400 students across 4 years. I mean, we really needed just a vast amount of data to kind of get at these questions, and it's only based on the foundation of so many measures within so many people, you know. But it's an interesting signal that would never show up in 30 participants going into a sleep study. Just simply the scale isn't there.
Mm-hmm. And when we look at these new, especially this new data being collected at such a larger scale, it's not just that you have the increased number of participants, it's the biggest size increase, I'm guessing, would be that you're running the study over the course of, say, 4 years. That's a long, long time to be collecting data. And when you're processing this data, analyzing this data, do you find that there is a lot of room for more advanced, say, computer science techniques to be used? For instance, in a bunch of the other fields that are starting to use data science right now, especially in the industry, we see tools like machine learning or things like that being applied a lot more to just this enormous amount of data collecting for the first time.
Yeah, absolutely. I mean, that's actually something I think is very interesting, because one of your questions was sort of like what's possible now. And that's one thing I thought about, was it's sort of a two-part process. On the one hand, we can actually get these vast amounts of data, but on the other hand, we need to process and utilize this vast amount of data. So it's kind of like I prepared a little illustration. You know, the idea being that if you're in a forest but all you have is a pocket knife, you may be able to kind of use one tree at a time. You know, but you need that industrial chainsaw to be able to use all of what you're presented with. So definitely, absolutely, it's the vast collection of data in parallel with the tools to process that data. Things like machine learning, you know, and really the field of statistics in general has undergone a renaissance. You know, the stuff that they taught me in grad school hasn't really been as useful even 5 years later, because the methods have evolved so much and they continue to evolve, which is great. But again, kind of to throw it back a little bit, a lot of these machine learning methods, they're still very black box. They can find relationships, but they don't necessarily explain them. So there's always going to be room. You know, it's sort of like, this is the new method. I think future technology will maybe help the machine learning be more explainable, but right now it's kind of very black box.
Mm-hmm. And when it comes to the individuals like working on this kind of research, I remember in another conversation we were having about, the guest was talking about the technology of holography. There was often a background of people who worked with the hardware. There was often a background of people who understood the physics. But when it came to the software end of things, because people were integrating into the field, so you might have computer scientists coming into the field afterwards, it always felt like, when compared to mainstream computer science versus the methods used in the particular field, that the particular field was lagging behind. Do you think that's the case, where we don't have as much of the advanced approaches or the people working at the edge of the, say, AI industry or anything else in computer science now coming into psychology?
Well, I mean, collaboration has always been a benefit to both disciplines. I mean, just as we were kind of talking about the tools needed to do this kind of thing, I mean, the amount of programming, this is the kind of thing you can't do by hand. In grad school, we learned things like, this is how you run an ANOVA. You can calculate all the little individual values and run your 30 participants. You could spend a couple hours, but you could do it, yourself. We're talking hundreds of thousands of data points. It would be practically impossible. But when you get into these data sets, there's sort of emergent issues that maybe psychologists aren't necessarily used to working with. So for instance, how do you store this amount of data? How do you access it? How do you get the specific parts of it that you want? How do you sort it by, say, a category of interest? These are sort of higher level questions that computer scientists are very familiar with and have the methods to solve. But then it's a flip side, and it's a collaboration, because in working with machine learning experts and other computer scientists, the theoretical knowledge takes a long time to kind of get and apply. So things like, why should these variables be interested or you can include everything in a model, but sometimes you get really nonsense things, like you might see something where that says your favorite color determines how tall you are. You'll find those kind of things will come out of machine learning, and you're like, of course, there's no logical association, or at least I don't think there is. There's no logical association between those, but that's where the theory can really help, and that kind of is what these disciplines apply. And there's things like heart rate, knowing when it should be different. One of the fields that we're looking at now actively is how accurate is heart rate in measuring stress from wearables. People wear these devices, but it's really about context, because heart rate changes for a lot of reasons not related to stress, things like standing up, things like not drinking enough water. There's a whole host of things out there, but that's where the theoretical knowledge can really help explain, or interpret computer science. And really together, the intersection of these disciplines is very powerful, much more powerful than either alone.
Definitely. And when we start to consider how this power is being used, as you mentioned, you very much like to think about the applications of how we can take this out of the laboratory and into real life contexts. And I know some of your research focuses not just on sleep science, but also on general worker productivity, which might incorporate things about their sleep, but also things like personality, etc. Could you talk a little bit about some of these applications that we're starting to see from different domains of psychology and them being applied into the workplace? And it would be great to hear about any examples there.
Yeah, so you definitely hit it on the head. Stress and sleep are very much tied to mental capability. Like we were talking about with the states earlier. If you wake me up and I've only slept 5 hours, you're going to get a whole different level of capability than if I slept 10 hours and felt well rested. And there's a lot of good reasons. In the laboratory, you can kind of control those things. You can say, as part of this experiment, I need you to sleep 8 hours or 5 hours. You can control that. But in the real world, there's a lot of things we don't control, like injuries or surprises or changes in family circumstance. Maybe you have a relative who needs specific, a lot more care, palliative care or something like that, where these things will echo throughout your entire life. And so if you can differentiate, say, an employee who is having these particular difficulties, but who is likely to, say, resume normal functioning after this event is over, that might be useful to promote productivity. And again, it's not just an employee getting one up on their on their employer or vice versa. I mean, the other thing is, if you can be aware of these things, allowances can be made, corrective actions can be taken. Maybe instead of firing a person, maybe you just give them some extra PTO or paid time off, and then allow them to recuperate to the level that you need them to be to perform. And those people, of course, would appreciate it and be happy to have some more paid time off, I'm sure. But again, there's lots of research out there that shows that happy, healthy employees are more productive. So there is a very specific interest from an employer side to improve those factors and to make sure that they can do what they can to make people happy. And so we maybe can generate some suggestions for things that can be done to make people happier or healthier. But this also gets at another issue, kind of like the dark side of the applied science on this side is privacy and productivity. So one of the big risks of doing these kinds of research is the vast amount of data can be very personal, or can be much easier to tie back to particular individuals. So of course, psychology is very much founded on privacy and ensuring safety to the participants. We don't want damaging secrets to get out about people, because not only would that be harmful to them, but they also might erode their trust in providing us that information the first time. I mean, especially if you're going to work with something sensitive like, say, alcohol abuse, if people don't tell you that they're doing it, you really can't learn anything useful, helpful, or otherwise. So you have to make sure that trust is there. And with these large scale studies, with this vast amount of data, you have to be very careful, much more careful than previous eras of research. That's a very big concern, is to make sure that data stays safe and stays private. Also, methods for that have also increased recently.
Mm-hmm. Is this kind of thing something that is, say, an ethical or regulatory consideration, or is this still starting to emerge as it's being voluntarily enforced or developed by psychologists right now, but there's no kind of standard that is set?
There are standards. So in particular, psychology is very familiar with the Internal Review Board, or the IRB. And so for decades, this governing body, and each institution has their own, they'll review these things for these concerns. It's just the difficulty I see is just that because technology is evolving so quickly, it's hard. I mean, 5 years ago, this kind of data wouldn't even be a problem. So not only do you have to recognize it as a threat, you also have to have knowledge on how to avoid that threat, and the threat is so new. So it's definitely an evolving field, but I think the IRBs have done a very great job in keeping an eye on these kinds of things. And they're doing just as much to further that research on how to protect people's privacy as people who are doing the research themselves. So it's definitely a concern. It's something that when we move into the real world becomes a more prominent concern, but there are methods to dealing with that, and there are people who can help. The IRBs are very useful in that regard.
Hmm. Do we have any case studies of companies applying this kind of technology and starting to see the benefits, but also the risks that we need to think about when this becomes larger scale?
The biggest ones, I think, were the Cambridge Analytica data scandal with social media and the worry that foreign nations were attempting to influence the US elections. There's kind of a vector through which nobody really had an idea that this could happen, or at least maybe they didn't believe it could happen. I'm not sure how the history of that all played out, but yeah, I think that's an example of where big data and all of this vast interface with participants could be an area of ethical concern or an area of practical concern that just simply wasn't a problem 20 years ago.
Yeah, and this gets into kind of the last line of questions I had for you, which were around the evolution of what comes after this. Obviously, like you said, technology is growing faster and faster, and it's really, really hard to keep up sometimes. But because of the prominent role that this plays in our lives, it's also becoming more and more important that we start to get this right. So not just thinking about the risk, because it's easy to get caught up in the risk, but there are
Sure.
also a lot of benefits. What are some of the biggest unknowns in this kind of research? So where there are research gaps that need to be addressed in the next 5 years? And just where do you think more attention is needed, or even where you're more excited to work on when it comes to the next 5 years?
Yeah, so I have a couple answers to this. One, I think there will always be a need to engage with and figure out how new technology is impacting back on us, the user, because thinking about smartphones, it was great that we were connected, and more connected than we'd ever been. And then people kind of were like, well, that means now I have to answer emails on the night and weekends. And then people started saying, oh, people are looking at their phones all night and they're getting blue light in their eyes, and it's making it hard to see. There are many unintended consequences with these benefits, but this will always be the case. So I think sort of really understanding what these new technologies, kind of how they interact back with us, and for good and for, I mean, not just for bad, but also for good. I mean, I think about how news happens today, how information gets out, and sometimes you get really good things happening out of seemingly small things. Something goes viral and people donate to some cause, where in an era before social media, that never would happen. Those people would just be unhelped. But to get more at the fun stuff, the two things that I'm sort of most excited about are the Internet of Things and self-driving cars. So I don't do work on really the second, but the first, the Internet of Things, I'm very interested in, because the world is we're getting better at sensing what's going on in ourselves, around us, what our context is. We kind of talked about context a little bit, and wearable sensors and other sensors, house sensors, smart homes, they can kind of pick up on that context. And with that context comes better decisions. For instance, if my smart home realizes that I only run water for 5 minutes at a time when I'm washing my hands or whatever, and it's been on for 30 minutes, it can choose to turn it off, knowing that this is an abnormal occurrence. And that could be just beneficial for everything, beneficial for my water bill, beneficial for the environment, not having my house flood. I mean, there's good contextual decisions will make the benefits of technology even better for us as users. And as far as the self-driving cars, I think this is a very interesting problem, because it's sort of twofold. We want cars to drive like humans drive, because we want them to stop when we would stop when we get the right signal. Even if it's a rainy day and you see a stop sign, we would still stop. We would want a self-driving car to do the same. And so I think that kind of gets at one of the understudied areas, or at least one of the biggest challenges. I think it's actually fairly studied, but I'm sure it's not an easy question, is how do we make decisions? How do we integrate all this information? How can we replicate that with sensors and with algorithms and processing and software? I mean, whatever level, and even probably multimodal self-driving cars, they use all kinds of sensors, even some that we don't have, like I don't have radar to judge distances, but they can use that kind of stuff. But I think it really does get into the question of how do we make decisions, and being better able to figure that part out will mean better understanding of self-driving cars, which I can't wait till they're a real technology that are effective in the nation and can be driven all the time.
Would it be accurate to say that it's kind of like the thing that's most needed is as we start to develop these more and more advanced technologies in the world, well, we're building them for ourselves. So we need to understand ourselves to be able to use them properly and even design like better versions. And that's where psychology of how we make decisions and all of these other factors is very crucial.
Mm-hmm. The more we know about the user and ourselves, the better of a design they will make, which will make it even better for the user. And again, you can also get a lot, it's sort of it's a cyclical process, because the user will identify new and exciting ways that it could be better. The technology will advance, and then and so on and so forth. So of course psychology is very much interested in the self and in the individual, and the changes and how it works across a wide variety of contexts. That spurs me on to think another area of research interest is just improving sensing of cognition and what's going on, affective states, stress, because stress research is charging ahead, but they've got a lot of space still to go. It's really hard to identify who's stressed, when, why, and how to solve it. Because you get a very sort of monolithic stress response. Regardless of why you're stressed, you have sort of a couple of body responses that happen, but the solutions to those problems may be very different. If I'm stressed out about an upcoming test, that might have a different solution to I'm exercising, which may have a different solution to I'm hungry. So it's that getting that context and figuring out really what's going on that makes these internal issues, being angry, being upset, being stressed, and then adjusting interventions that are sensitive to those contexts. Telling soldiers to go to sleep early may not be practical in their work environment, or or having truck drivers change or sleep on a regular schedule may not work for their profession. I mean, there's a lot of personalization or contextualization for these things that is a good area of development. And there's a lot of money to be made. I mean, a lot of wearables are out there. There's many companies that are producing these things, and they're doing really great stuff. And I think they're going to drive the individualization and the contextualization of these sensors.
It really gives an amazing context to how much more area there is to grow. We often understand this with technology, with how often these things get talked about, but with psychology, you don't as much think this is the crucial part of building anything. So it's really interesting to have had this discussion and think about how this technology and this science will progress forward together. Finally, I just wanted to ask you if someone was interested in learning more about the intersection of these two disciplines or about your work in particular, where might they go?
So I have a profile on ResearchGate that has all my current research. And then also there's Google Scholar is another great place. I guess another thing I would say is maybe the American Academy of Sleep Medicine and the Sleep Research Society. And then also there's a lot of new journals cropping up too, like Nature, Digital Medicine, Telehealth, things like that. Those are also great resources.
That sounds great. So I'm sure if anyone's more curious about this amazing field, they would be able to learn more there. And I just wanted to thank you for taking the time to join me today and explain a little bit about this rapidly evolving area of these two disciplines.
All right, I appreciate it. Thank you so much.